Alright, let's do another one. So today we're working on counting bits. Oh gosh, I am not a fan of doing bit manipulation type stuff. Given an integer n, return an array of answers of length n minus n plus 1 such that for each value inside the array is a number of ones in the binary representation. So for 2, so basically we count up from 1, or sorry, we count up from 0 all the way to n, and for each value we want the value within the array to be the number of ones. Okay. Interesting. Let's see. This is a weird one. I'm not gonna lie. It sounds like almost like a dynamic programming sort of approach might work here, but I'm not quite sure. What I do know is that if n is a power of 2, then it'll have 1, 1. And maybe that's actually the key to what we're doing. But is there a way to say, like, if... Basically, my question now is, how can we determine whether or not a number is a power of 2? Because from there we can say for each number we count up in a sort of contrived way. There's probably some math related stuff that we can do. We know that if the number is a power of 2, then for sure that it will have 1, 1. We know that 0 is the only number in binary that will have 0 ones. And any number in between can have between 2 and the number of bits that is needed to represent it, number of ones. If we do it in linear time and in a single pass, I'm still leaning towards maybe something DP-like, though I'm not entirely sure how. Well, first of all, let's just create a binary list or binary array is going to be mutable list of does mutable list of do sizing? I want to create a mutable list of a size. That might not be doable. So let's just do that. Int and then for I think it's var I to n, right? Because we want to start from 0 to n. Is that how you do for loops? I've already forgotten how to do for loops. I in. There we go. So we want to go up from 0 to the number itself, inclusive, so this is correct. But how do we do... Is there any binary stuff that we can do here? I don't think that's the type of binary we're looking for. Let's see. If it's a power of 2, then we set to 1. If 0, set to 0. So when I then binary array sorry, binary array add 0. How do we check if something is a power of 2? First of all, in Kotlin, but second of all, efficiently. So we have this part. Sorry, I'm a lot more coffee today. In coughing, not coffee. Maybe we do log? Let's take a look at the Kotlin math stuff. Log. So we'll have to import this. So import Kotlin math log 2. So what we'll do is that if log 2 of I is equal to log 2 of I dot 2 int, then binary array add 1. So basically, if if we take the log of it, and it's the same as the log of it, and we set it to an integer, then it's correct. But this is, we're comparing a float to ints to double. Let's be weird with it first. we can fix it later. Now the problem is how do we calculate the in-betweens? Okay. I started drafting this out on the tablet, and one of the things that just came to my mind that might work is that basically we always start at the most recent factor of 2, or yeah, the most recent power of 2. And based on the distance between our current number and the power of 2, we will add the power of 2, the number of zeros in power of 2, which is always 1, plus the distance we have from the power of 2. And that's the number of 0, or the number of 1s. It might work. The way that I'm looking at it right now, because the power of 2 will never be touched until the point where we will get another power of 2, then there will be no overlap. At least that's what I think. So we don't need to do this previous factor thing. And since the power of 2 is always going to be always 1, then we don't need to care about that either. So if it's 0, we add 0. If it's power of 2, then we add 1. Otherwise, actually we do need to keep track of that then. So let's say var most recent power of 2 is equal to -1. Most recent PO2 is I. Most recent PO2 so the difference between the most recent power of 2 and our current number plus 1. And I think this might work. This is a weird calculation though. Let's give it a run to see if there's anything else that we missed. Infer type is int, but double is expected. Log base 2. Is log 2... Oh, does that take a double? Oh, that takes a double. That's kind of awkward. Turning it into a... Is there a way to just, like, truncate? Oh, sick. Okay. Then we can just do truncate. Oh. Probably have to import it, though. Import Kotlin math truncate. And truncate. So if it's the same as it is truncated, or equal, then we can add 1. Let's see if we actually, if this actually works though. Gotta love the garbage truck rolling through. Let's do 5. Let's do 19. Looks like it's working. I think, you know what? Let's just do this in a native int array. Of size n. Since this seems to work, so binary array at I equals 0. Or we could just do set. I guess that's like a more functional way to do it. Set I 0. Set I to 1. And set I to this value. Oh, whoops. And we can just return binary array. And that will probably be marginally faster, but this... Oh, whoops. N plus 1, right. Cool. Looks like it works, and let's submit it and let's see if anything went wrong. Okay, cool. Honestly, I am very much surprised that I managed to think about that, but it took quite a bit longer than I expected, honestly, and something that hopefully I really hope that something like this doesn't really come up in an interview. Like, this is... I feel like this is more disconnected from the type of algorithmic thinking than, say, like, figuring out, like, how to manipulate a graph in a specific way, or returning a specific value from an array of integers. Like, this sort of binary stuff I don't think really is that much useful, especially when for me personally, I'm trying to work in something like mobile app development, and I don't expect this sort of binary stuff to come up at all. But who knows? Maybe this is something that has some esoteric signal in interviews that I'm not too sure about. But in any case, I'm happy with this. Memory usage is a bit high though. But hey, I mean, it works. So yeah, I'm happy with it. But in any case, that's all for today, and I'll see you for the next problem.